Hello, discrete math fans. We're going to move on to doing some more induction. This is part 2. We're doing some more complicated types of induction. We've been using induction to prove various integer sum formulas. It turns out that induction can be used to prove other kinds of things: divisibility relations, inequalities, geometric statements. I would like you to read through the proof in the book about how to tile a square region with L triominoes. This is known as Golems Theorem, which is named after Solomon Golem. It's a very surprising theorem, but it's a really elegant bit of mathematics and a surprising use of induction. Now let's show how induction can be used to prove a statement about divisibility. So as an example, let's prove that for all n in the natural numbers, 6 divides 7 to the n minus 1. So we're saying that no matter what n is, 7 to the n minus 1 is divisible by 6. All right, so let's let p of n be the predicate that 6 divides 7 to the n minus 1. It's a predicate because there's a variable in there. We don't know what that variable is, so until we know what that variable is, we don't know if this is true or false. Notice that when n is equal to 1, then 7 to the n minus 1 will just be 6, and that's obviously divisible by 6. So that tells us that p of 1 is true. Now let's let n be a natural number. It is an arbitrary but particular value of n, and let's assume that p of n is true. That is, we're assuming that 6 divides 7 to the n minus 1. So, what does the definition of divisibility tell us? It tells us that there exists a k in the integers such that 7 to the n minus 1 is equal to 6k. So now we want to prove p of n plus 1 is true. So that is, we want to prove that 6 divides 7 to the n plus 1 minus 1. So we need to find a way to try to leverage our knowledge about 7 to the n minus 1 to prove something about 7 to the n plus 1 minus 1. Okay, so 7 to the n plus 1 minus 1, we can pull out a 7, so that turns into 7 times 7 to the n minus 1. And now we can replace 7 to the n with 6k plus 1. How does that happen? Well, remember that we are assuming that 7 to the n minus 1 is divisible by 6, and so we know that 7 to the n minus 1 is equal to 6k. So just move the 1 to the other side, and you've got 7 to the n is equal to 6k plus 1. So now notice that I've marked this step as being the step where we use the inductive hypothesis. Now a little bit of algebra to move things around. So we distribute the 7 and clean it up and pull out the 6. And now this is what we're after. We're trying to show that 7 to the n plus 1 minus 1 is divisible by 6. And I think we've actually done it. So because 7k plus 1 is an integer, 6 divides 7 to the n plus 1 minus 1. And we can conclude then that p of n plus 1 is true. And so, by the principle of mathematical induction, p of n is true for all n in the natural numbers. And that's the end of the proof. Okay, that's all for now.